All right, let's jump right into this. Welcome to today's explainer, everyone. Today, we're going to break down the exact physics concepts from your grade 9 textbook chapter on work, energy, and simple machines. As your virtual science teacher today, my absolute biggest goal is to make these concepts crystal clear, point out those sneaky little traps that catch students on exams, and make sure you truly understand the physics governing our world. So, here is our roadmap for today. First, the science of work. Second, positive versus negative work. Third, energy, specifically kinetic and potential. Fourth, power and rate of work. Fifth, how simple machines help. And finally, number 6, a quick summary and quiz to wrap it all up. To kick things off, honestly, just take a look around you. Whether it's the food giving you the capacity to walk, electricity spinning a ceiling fan, or fuel driving a car down the highway, energy is literally the heart of every single activity in our daily lives. Nothing happens without it. But how do we accurately measure what energy actually does? Let's find out. Topic 1. The science of work. Force times displacement. Okay, so in science, the word work actually means something totally different than what you might think of in everyday life. You'll definitely want to memorize this definition and formula for your exam. Scientific work is only done when a constant force is applied to an object, and that object actually moves, meaning it has displacement in the exact direction of that force. Let's look at a really practical example. Think about lifting 5-kilogram bags of wheat. If you lift 3 bags instead of 1 up to a height of 1 meter, you are doing exactly 3 times the work, simply because you need 3 times the force. On the flip side, if you lift just 1 bag, but you lift it 3 meters high instead of 1 meter, well, you're proportionally multiplying the distance. Either way, increasing the force or increasing the displacement increases the total scientific work done. Makes sense, right? Now, huge misconception alert here for your upcoming tests. Holding a heavy grocery bag perfectly still or studying super hard for 3 hours might feel absolutely exhausting to your body, but because there is zero physical displacement of an object, in physics, you are doing zero work. A really great memory trick to keep in your back pocket is no distance, no work. Scientific work requires actual movement, like physically pushing a moving box. Topic 2. Positive versus negative work. Direction matters. Let's do a quick mini quiz. Take a guess. If you apply a force, but the object moves in the completely opposite direction, is the work positive or negative? Think about friction acting on a sliding box. The box is moving forward, but friction is actively pulling backward. Because the force of friction and the displacement are in opposite directions, the work done by that specific frictional force is negative. Topic 3. Energy, kinetic, and potential. Let's transition over to energy, which is basically just defined as the capacity to do work. Picture kids playing on a slide. The one moving fast at the very bottom has high kinetic energy, all thanks to their rapid motion. Meanwhile, the kids waiting at the very top aren't moving yet, but they have a ton of potential energy simply due to their elevated position against gravity. And here is an absolutely crucial rule: the conservation of mechanical energy. The sum of the kinetic energy and the potential energy of an object falling freely remains entirely constant. This total mechanical energy isn't just magically created or destroyed, it is conserved. It just transfers back and forth from potential to kinetic as the child slides down. Now, here's a really tricky exam point to watch out for. Does work done against friction lead to the storage of potential energy? The answer is a hard no. Work done against internal forces, like gravity, definitely stores energy, like when you lift a heavy book onto a top shelf. But work done against friction, that just creates heat. It doesn't store any potential energy at all for later use. Topic 4. Power and rate of work. Basically, how fast work actually gets done. So we know what work is, right? But what do we call the rate at which that work is done? Doing 1,000 joules of work over a whole day is very different from knocking it all out in 1 second. This brings us to power, which simply equals work divided by time. Power is measured in a unit called watts, named right after the brilliant scientist James Watt. Let's do a really quick calculation. If a car engine changes kinetic energy to do 200,000 joules of work in just 10 seconds, what is its power? Well, you just divide the work, 200,000, by the time, 10 seconds. And boom, you get a massive power output of 20,000 watts. Topic 5. How simple machines help, changing magnitude or direction. Now, what if we want to do that physical work, but, make it a bit easier on our human bodies? Let's see how this ties right back into our first section. Simple machines, like a basic pulley system, don't magically change the total amount of work required, but they do make the task vastly easier by changing the direction or the magnitude of the force you need to apply. I mean, pulling down on a rope is way more convenient than hauling a heavy weight straight up. Think about this everyday scenario. Why is it so much easier to pop the tight lid off a can using a spoon as a lever? Or why do you use scissors to cut something hard? These are all simple machines multiplying your effort. A small force applied by your hand over a larger distance suddenly becomes a large force over a small distance, effortlessly popping that lid so you don't have to strain yourself.
Section 6. Summary and quiz. Reviewing key concepts.
All right, we've covered the whole chapter, so let's lock in this knowledge right now. Here is your ultimate revision checklist, summarizing the core definitions. 1. Energy is the capacity to do work. 2. Work equals force times displacement. 3. Power is the rate of doing work. 4. Simple machines make work easier by changing force direction or magnitude. I highly suggest you grab a quick screenshot of this to study right before your test. Also, please remember this vital distinction for your multiple choice questions. Work and energy both share the joule as their standard unit, because doing work is literally the act of transferring energy. However, power stands alone with the watt. Do not get those mixed up on exam day. I'm going to leave you with a provocative thought to test your true understanding of energy dynamics today. If you can never create energy from nothing and some energy is absolutely always lost to negative work like friction, could a machine ever truly run forever? Why do all real machines eventually slow down and stop, making perpetual motion machines impossible? Think about how energy transforms in the real world. Keep learning, keep questioning everything, and thanks for joining me in this explainer.